Okay, so this is section 4.5, graphing sine and cosine. And to graph sine and cosine, and actually to graph any of your trig functions, you're going to use your transformations procedures that we had back in first semester. So we're going to graph y equals 2 sine of x minus pi over 2 plus 1. And same as with our transformations, we want to look in our parentheses and make sure we have just a 1x to see whether we have to factor out our b value. In this case, we don't, so it's going to make things a little bit easier. All right, let me move that around for myself. Now, nice thing about our trig functions is it's different than what we did previously in our transformations. Is our points for the individual equation is going to stay the same, our starting points. So in this case, I'm going to make a table here. Give me a second. All right. I'm going to get rid of that table here. All right. I'm going to have my x and my y over here. The values for sine that I'm going to use are my x and y's. They're going to come from my unit circle. So I'm going to use 0, and the sine of 0 is just 0. Pi over 2, 1. Pi, 0. 3 pi over 2, negative 1. 2 pi back to 0. I almost put something else there. Hold on. 0. And the reason we only use these 5 points is because we know exactly where they are. They're going to give us exact points to plot on our graph. And so you don't have to use anything else but these ones. Now, let's do our transformation. Same as before. We're going to take x divided by b and y times a. All right, so the same things we did before. No different. Well, my b value is 1, if we look in our equation. My b is 1, so I'm just dividing everything by 1, so that's not going to change. So I'm still going to have the 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now for my y values, my a is 2, so I'm multiplying all my y's by 2. 0 times 2 is just 2. 1 times 2 is 2. And 0 times 2 is 2. Really? Hold on one second. Let me erase this. Can you tell it's been a long day? Now, back to 0 times 2, and that's 0. Negative 1 times 2 is negative 2. And 0 times 2 is also 0. Notice in the original points, I had 0, 1, 0, negative 1, 0. I had 3 zeros. Every other value was the same. The first, the third, and the fifth were the same y values. I need the same thing here. The first, the third, and the fifth y values should be the same. If they're not, I've got a mistake. So that's a quick thing to make sure you have, that you did them right. Now, our last set of points. Hold on a second. I'm trying to get this to move for myself. All right. I'm going to take my x divided by b. And I did not give myself enough room here, so let me make this a little bit bigger here for myself. x divided by b plus c. Now I know Mrs. Armstrong uses c divided by b. I just use c. It's the same thing. You look in the same spot in your equation. Y times a plus d. So my first x value is 0 plus pi over 2 gives me just pi over 2. Pi over 2 plus pi over 2 is just pi. Pi plus pi over 2. Give me a second here. I'm just trying to adjust something. Pi plus pi over 2 is 3 pi over 2. And 3 pi over 2 plus pi over 2. 3 plus 1 is 4, divided by 2 is 2 pi. And then 2 pi plus pi over 2. And that gives me 5 pi over 2. All right? So those are my final x values. Now to find my y's. And honestly, your x values are going to probably take you longer to do because they're going to be fractions. All right. So now to find the final y values. Take our y and add our d. And our d is 1. So 0 plus 1 is 1. 2 plus 1, 3. 0 plus 1 of 1. Negative 2 plus 1, negative 1. And 0 plus 1 of 1. Okay, so now we have our final points. And again, just as a quick check, you want to make sure your first, your third, and your fifth y values are the same. Now let's graph this. Now if you look at your x values, you don't have any negative x's, so you don't have to show a huge negative x-axis. Alright, and I am going to try and make this so that you guys can see it clearly. It's going to be kind of small, but you now need to determine your scale. Well, I'm counting up by pi over 2, so that's probably the best way to go, is have your scale be by pi over 2. Now, for me to get that to show on here, I may have to do every other one. So let me see if I can write it small enough. Okay, that seems kind of big, so I'm going to actually go skip 2 lines, and this is pi, 2 pi, and then 3 pi. I can't write it smaller than that. I'm sorry, guys. Count up by probably 1, 2, 3, and then negative 1. And I'm going to try to erase and get this to write better. Let's see if I can do that. And you do need to include your scale. We have to see what you're counting by. So now just plot your points. Pi over 2, 1. Pi over 2 is right here, 1. Okay. Pi is at 3. Three pi over 2 is at 1. 2 pi is at negative 1. And then 5 pi over 2 is back to 1. And now we just connect them. Don't forget your arrows, guys. That's not perfect. Let me see if I can do it better. I'm trying really hard to make it look nice and smooth. Okay? Now this is just one period. This is one revolution around the circle. we have infinite amount of revolutions we can do. So that's why we have to put the arrows. You have to remember the arrows. And this one revolution is called a period. Now, that's part of our laundry list of things to do, is we have to determine a few things. First one is amplitude, AMP. So let's go through and we're going to just make our list. Amplitude is how much does those original 0 points that we had, how much does the graph go above it or below it? Amplitude can be found by taking the highest value, which is 3, minus the lowest one, which is -1, and then dividing by 2. Or you can also look at, in this case, you can look at your A value. So if you don't remember that it's your A value, it's 3 minus -1 divided by 2. The highest Y value minus the lowest Y value. And that's going to give me 2. My period is, for sine and cosine, the standard period is 2 pi divided by b. In this case, my b is 1, so it's just divided by 1, which comes out to be 2 pi. My phase shift can be abbreviated as PS. Phase shift is how much does it move to the right or left. So, going back to my rules for transformations, phase shift is that C value, and that's a positive pi over 2, so it went to the right, pi over 2. Vertical shift, how much did it go up or down? Well, it went up 1. Excuse me. Now, domain. Looking at this graph, my domain is going to keep going based upon my revolutions around the circle, so my domain is all real numbers. My range is the lowest y value to the highest y value. Well, that's -1 to 3. Now to get an x-intercept. X-intercept means I'm going to put it equal to 0. Well, that's going to be a trig equation. We haven't quite learned how to do that yet, so we're going to just kind of put trig equations for right now, okay? But you will soon learn how to solve that, and you'll be expected to remember it. Y-intercept. There's only one y-intercept, so that's not going to be that bad. But see, with the x-intercepts, that graph's going to constantly going through that x-axis. So we have to show every single one of those, and that's why we have to do trig equations. So for y-intercept, we're going to put 0 in for x. Two times the sine of 0 minus pi over 2 plus 1. Well, let's just solve this. Y equals 2 sine negative pi over 2 plus 1. Well, the sine of negative pi over 2, sine of negative pi over 2 is just -1 plus 1. That's going to give me -1. So the y-intercept is just 0, -1. And our last, asymptotes. Well, if you look at your graph, there are no asymptotes. Sine and cosine don't have asymptotes because you can have any value for x. And the y values are all going to, for every value of x, there's going to be a y value. So there's no asymptotes. Nothing is undefined. Okay. There's the first example. The other ones will go faster. Okay. Okay, so let's go to the second example, which is y equals 1/2 cosine quantity 3x minus pi minus 2. So in this case, we do have a value that's in the parentheses that we need to factor out, so let's factor that out before we do anything else. So I'm going to factor that 3 out, and that's going to give me x minus pi over 3 minus 2. Now we still do the same thing. We have our a value. Now b is 3. We have our c, which is pi over 3, and we have our d, which is negative 2. Now the numbers you start with, the values for cosine, are a little different than sine. Okay? But they still come from the unit circle. The x values don't change. So it's 0, pi over 2, pi, 3 pi over 2, and 2 pi. My y values? Well, the cosine of 0 is 1, so this one starts at 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is back to 0. And the cosine of 2 pi is 1. So now, where sine had the first, the third, and the fifth y values were the same, this one, the second, and the fourth one are. Okay, but it's still using 1, 0, and negative 1. That's it. Okay, so now let's do our x divided by b. So 0 divided by 3 is still 0. Pi over 2 divided by 3. Well, dividing by 3 is the same as multiplying by 1/3, so it's pi over 2 times 1/3. That's going to be pi over 6. Pi divided by 3 is going to be pi over 3. Three pi over 2 divided by 3 is going to become 3 pi over 6. I don't want to reduce it right now because of the fact I've got a common denominator going in here of 6, and that's going to help me with graphing it. And we want to keep that denominator. In your tables, you don't need to reduce your fractions. I don't, unless they come out as something that's easy to work with. 6 is not as easy to work with as if it's a pi over 2. So I leave them alone. And then the last one is 2 pi divided by 3, and that's 2 pi over 3. Okay? Because we can easily convert those pi over 3 and that 2 pi over 3 to have a denominator of 6. That's going to help us when we go to graph. And as always, again, like I said, we're not going to check your tables. The tables are just for you. Y times A. My A is 1/2. So 1 times 1/2 is just 1/2. 0 times 1/2, 0. Negative 1 times 1/2, negative 1/2. Back to 0 times 1/2, that's 0. And 1 times 1/2, and that's 1/2. Now to do our last table. And I'm going to actually give myself a lot of room on this one because I'm going to have to work with fractions. So I want to give myself plenty of room. Okay. And this is mainly just for those x values because that's where my fractions are. So the first one is 0 divided by 3, which is still 0. Okay, so this is going to be the x, hold on here, x divided by 3 plus my c value. In this case, it's pi over 3. Okay? So 0 plus pi over 3 is just pi over 3. Now this table is going to be a little bit bigger because I am going to be using more space to write my fraction so you guys can see it. Now I have pi over 6 plus pi over 3. Common denominator for that pi over 3 is going to be 2 over 6. So it becomes 3 pi over 6. The next one, pi over 3 plus pi over 3, and that is 2 pi over 3. Next we had the 3 pi over 6. Plus the pi over 3. Hold on, let me see if I can write this a little smaller. Well, that pi over 3 changes to 2 over 6, so that becomes 5 pi over 6. Yeah, I'm sorry about that. I don't write small. And the last one is then 2 pi over 3. Let's see if I actually can't fit that in there. So then 2 pi over 3 plus pi over 3. That's just pi. Now if we go back up and look at this table, if we changed everything to a pi over 6, or to a denominator of 6, that pi over 3 changes to 2 over 6. Then I have 3 over 6. 2/3 changes to 4 over 6. 5 over 6, 6 over 6. So everything's increasing by pi over 6. That's good. Okay, so it's a pretty good indication I want to count by pi over 6 on my scale. Now, I'm going to take that AY, so I'm going to take my Y times that 1/2 minus 2. So it's going to be 1/2 minus 2, and that's negative 1.5. 0 minus 2 is negative 2. Negative 1/2 minus 2 is negative 2.5. 0 minus 2 is negative 2. And then 1/2 minus 2 is negative 1.5. Okay, so now I have all my values. Now let's graph it. Okay. Again, like I said, if you look at your x values, the common denominator of all of them is 6. So let's count by pi over 6. And again, my x values, I don't have any negatives, so I'm not going to make a big negative on the x side. I don't have to show much of that, but I do have negatives on my y, so I want to make sure I show that. Do I have any positive y's? Nope, so I don't have to. Just going to do this. Okay. So I'm going to count by pi over 6, so this is going to be negative pi over 6, pi over 6, and I'm actually going to count, so I'm having trouble. Pi over 6, this will be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, pi, 7 pi over 6. Sorry about how I'm counting it, pi. But that's, otherwise you wouldn't be able to see it. And then we can go by, so this is going by half, so maybe we're going to count by negative half. So negative 1/2. So every other one's going to be negative 1, negative 2, negative 3. Now let's sketch it. So pi over 3 is that's going to be, that's 2 pi over 6. So that's 1 pi over 6, 2 pi over 6, down to negative 1/2. Right there. 3 pi over 6, we're at negative 2. 4 pi over 6, we're at negative 2.5. 5 pi over 6, we're back up to negative 2. And then we're at 6 pi over 6, which is just pi, and we're back up to negative 1 1/2. Now, kind of looks like it's supposed to look like an absolute value graph. Do not make it straight. It is a curve. Okay? Put your arrows on the ends. Okay? So now let's do our list. First thing, domain. Oh, actually, let's do amplitude. I'm sorry about that. Amplitude. My highest y value is negative 1 1/2. My lowest y value is negative 2 1/2. They have a distance of 1 divided by 2, and that's 1/2. You might start noticing that this amplitude is also your a value. Good indication. Your period. Period is found by taking 2 pi divided by your b. Our b is 3, so it's 2 pi divided by 3. Phase shift. Phase shift is how much did we move to the right or left? Well, going back up to my equation, we moved to the right, pi over 3. Vertical shift. Up or down? We went down 2. The domain. Domain for sine and cosine are all real numbers. Always. Range. My lowest y value is negative 2 1/2. My highest y value is negative 1 1/2. My x-intercepts. Well, does it ever cross the x-axis? No, because this is going to continue going in that same pattern, so it's never going to hit the x-axis. There are none. Y-intercept, though. Well, we've got to calculate that one. We're going to have to put 0 in for x. And I'll go back to the original equation for that one. So 1/2 cosine of 3 times 0 minus pi minus 2. 1/2 cosine of negative pi minus 2. Well, the cosine of negative pi is just negative 1. So it's 1/2 times negative 1 minus 2, so negative 2 1/2. So my y-intercept is at 0, negative 2 1/2. Again, there's no asymptotes with sine or cosine, so you don't have to worry about that. They do not exist, or there's none. Even, odd, or neither. So if I were to continue this graph, does it look like it's centered around your x-axis or your y-axis? No. So it's neither. All right. Okay, so let's go on to the next graph. This is the final example. And this one, I made it a little more nasty with the fractions. All right. And that's going to be y equals negative sine (3x) plus pi over 2 minus 1. Factor out the 3. Factoring out that 3 is the same as dividing by 3, so that becomes x plus pi over 6 minus 1. Okay, so let's start with our points. Our x and our y. So 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, 2 pi, 0. Okay. Now let's do the x values. X divided by b. So 0 divided by, hold on, this is flashing at me. I am probably going to have to start on a new video. Okay? I'm sorry about that. So there will be a part 2 to this one.